The purpose of this lesson is not necessarily to teach you how to add and subtract fractions, as it is towards guiding you along the problem-solving aspects of adding and subtraction of fractions. If you need a more in-depth review regarding adding and subtracting fractions, you need to go back to my older lessons that I've made that go more in depth with illustrations and pictures and that sort of thing. Here, I will review how to do it, okay? But I'm not going to review the why. I'm going to review the what to do, not why we do it. Okay, so again, go back to my other lessons if you need a more in-depth review. The number one rule in fractions, when you add or subtract them, it's the same principle. You have to make sure the denominators, the bottom numbers, the denominators have to be the same number. Thankfully, in this first question, they are the same number. If they are the same, you need to just add the numerators. 2 plus 2 is 4. Let's make it yellow. Make it match yellow. So we have 4 over, what, 6? Do we write 6? No, we don't write 6. We write 3. The denominator has to stay the same. 2/3 and another 2/3 makes 4/3, okay? Now we can convert this to a mixed fraction if we need to, and that would become, let's see, 3 goes into 4 one time, and that leaves 1 left over 3. And we can check that over by going like this. Multiply these two and add the last number. 3 times 1 is 3, times 1 plus 1 more is 4. So we get that back, which means we did it correctly. They match. Now we can move on to question 2 where the denominators do not match. You see that? They're different. So we have to, remember, multiply or divide them to turn them into the same number. So let's count here. Let's count by 3s. 3, 6, 9, 12. Count by 4s. 4, 8, 12. Okay, they can both become 12. So we can multiply the 4 by 3 and then do that to the top. You have to make sure that it's the same thing. If you times this by something, you got to multiply the top by the same thing. And then this one here, we can multiply by 4 and multiply that one by 4 because then we can get the 12s that we need. So that'll become a 12. And let's do that. Let's cover it with green. That will become 12. Let's do this. 12. And the numerator would become, let's see, 4 times 1 is 4. And then we put our plus sign and we can go 4 times 3 is 12. Our numerator becomes 9, not 6. 3 times 3 is 9. Don't confuse that. It's an honest mistake, but an unforgivable one. Don't do that. Now we add them together. We get, let's see, 4 plus 9 is 13. So that makes 13 over what? 24, right? 24? 12 plus 12, no, just 12. Keep the denominator the same. And that's our answer. And if we need to, reduce it. Make sure it's reduced. Yeah, nothing can go into both of them. Now we can turn it into a mixed fraction. Let's see, 12 goes into 13 one time. That leaves 1 left over 12. And we can check it by going 12 times 1 plus 1. It does make 13 over 12. We did it correct. Now I'm going to move all this to the side to make some space for the last question. So off you go. And this too. No, you stay back there. Okay, let's add this one here. Look, if you see a mixed fraction, the first thing you need to do before you worry about the denominators is turn them into improper fractions. You have to do it that way. I'm not going to say it's the best way to do it, but yes, it's the best way to do it. Do it that way. 5 times 2 plus 2 makes what? 10, 12. So this becomes 12 over 5. And this becomes 4 times 1 plus 3 is what? 7? 7 over 4. Now look at the denominators. We did step 1. We turned them into mixed or improper fractions. Now we can worry about those denominators. 5. Now count by 5s with me. 5, 10, 15, 20. How about 4s? 4, 8, 12, 16, 20. Aha, we got our number. They can both turn into 20s. Times this by what? Yeah, 5. So we have to times that by 5. Now what do we times that by to make 20? That's right, 4. So we have to times that by 4. What does that turn into? 48 over 20? 48 over 20. And this becomes 35 over 20. Look at those denominators. They are the same. We just add the numerators now. What's 48 plus 35? What is that? Okay, 5 and 8 is 13. Carry the 1. You got 83. So we can go 83 over 20. Let's see if we can reduce it. 20 to, what goes into both of them? Let's see, is 3 divisible? No, 3 doesn't work. 4, no. 5, 6, 7, 8, no. What else goes into 20? We're out of numbers here. This is lowest terms. Write it as a mixed fraction. 20 goes into 80. Let's count. 20, 40, 60, 80. 4 times. 3 left over, right? Over 20. Good. 20 times 4 is 80 plus 3 is 83. Look, if this was complicated, what I just did, you need to go back and review those lessons that I've made on mixed fractions before you move on. Subtracting them would be the exact same principle, except we subtract numbers instead of add them. So we have common denominators, so we just subtract the numerators. We get 4 over 3. And then we see 5 take away 1 is 4, and then the denominator is the same. And that makes 1 whole and 1/3. This question here, look, we have a 3 and an 8. What can they both be turned into? Okay, count with me. 3, 6, 9, 12. None of those 8 goes into. 15, 18. Does 8 go into 18? No. 21, 24. Yes, 8 goes into 24, and so does 3. So we're going to times this by 3 to make 24. And we're going to times that by 8 to make 24. It's almost like the numbers switched. And then we can get 8 over 3, or no, 8 over 24. Here we get 3 over 24. We subtract them. What's 8 minus 3? Yeah, 5 over 24. Reduce it. It's reduced. Here we have another one. Mixed fractions. Let's fix those up. Convert them. 5 times 1 is 5. Plus 4 is 9. 9 over 5. 3 times 2 is 6. Plus 2 is 8 over 3. Bad denominators. Really bad. One's a 5, one's a 3. They need to be the same. Let's count here. 5, 10, 15. Oh, I think 3 goes into 15 as well. So what do we multiply it by? Did you say 3? Yeah. Good work. Times that by 3. That's going to turn into 50. Now look, what do we times this by? 3 times 5 is 15. So we times that by 5. Now we're going to get 27. We've got 27. You know what I'm going to do? I'm going to flip these around because then we're going to get negative numbers. You know what? Who cares? Let's do negative numbers. We're going to get 27 on the top over 15. And we're going to subtract 40. Oh, yeah, baby. We've got 27 minus 40. What's that going to be? Come on, use your subtraction skills. Use your integers. Yes. Minus what? Negative, what is it? 13 over 15. There you go. Now, the review is done. We're going to go into the word problems. You identify addition word problems by these words: total, sum, and altogether. There's not much more they can ask you. Find the total of something, find the sum of something, and find whatever we have altogether. Memorize those. You need to understand them. Subtraction, there's a lot more tricks to it, and they're going to try to fool you. Difference, most people understand, hey, the difference means subtraction. Yeah, you take one thing, you find another thing, you get the difference between them. Yeah, okay. But here's another one. How many remain? That's another one most people understand. If it asks you how many are remaining, how many are left over? Okay, those are all subtraction type questions. But here's where it gets tricky. How many more are there? Okay, sounds like addition. It's not. It's subtraction. We're comparing two things, and essentially we're being asked to find the difference between them when it asks us to state how many, or to figure out how many more there are. So this is subtraction. How many less? Most people would figure that's subtraction. And then what I like to call, these are the ER words. Memorize the ER words. How much farther is something? How much shorter is something? How much longer is something? Sounds like addition, farther, longer, but there's subtraction. If it ends with an ER, how much, and then an ER word, you've got yourself a subtraction type question. So what do we have? Difference, how many remaining, how many more, How many less? Those ones are, you know, you need to understand those. Most people will get those, except this one. This is a trick one. I'll put a star beside it. And then the ER words. Try to close your eyes and recite as many of the subtraction clues as you can. Are you thinking difference? Are you thinking of the ER words? How much more, how much farther, how much longer, how much shorter? Can you think of more ER words? How much wider, how much smaller, how much shorter? Well, shorter was on there. But those are all examples of ER words that all mean the same thing. Subtract. See how many more you can do before we move on. Here's a question. Sandy jumped this far. Josh jumped this far. Who jumped further? Farther, further. Who jumped further? Sounds like subtraction, right? ER word? Nope. It doesn't ask us how much further. It just says who jumped further. If you look back here, it says how much. There has to be the how much before it. So here's just who jumped further. Who did? Was it Sandy or was it Josh? Now you could line these up. You could say, okay, that's 4 times 2 is 8 plus 3 is 11. So that's 11 over 4. And this is 8 times 2 is 16 and 3 is 19. 19 over 8. And then you could say, okay, well, we need the denominators to be the same. So we can turn this, we can double both of them. And that would change this to an 8 and this into a 22. Aha! 22 over 8 is more than 19 over 8. So Sandy jumped further. That would be good if you were asked to show your work. But this question here doesn't really specify. What if it said estimate, using estimation skills? Here's what you would do. They both jumped 2 meters. But Sandy jumped 3/4 more, and Josh jumped 3/8 more. Which is greater between these two? Since these are tied, we're going to go to the fraction. Is 3/4 more or is 3/8 more? Of course 3/4 is more, right? Why? Because look, 3 out of 8 is less than a half. 4 out of 8 is a half. 3 out of 8 is less than a half. 3 out of 4 is more than a half, right? 2 out of 4 is, so this is more than a half. This is less than a half. This one wins. So Sandy. Read the next question to yourself. What is it? Adding or subtracting? Yes, it is. How much further? That's subtraction. So we're going to subtract, let's see, 11 out of, let's see, 4 times 2 plus 3 is 11 out of 4. And this one was, what did we say, 19 out of 8. We're going to turn these into common denominators. So this one will be times 2 times 2. This one we'll leave alone. This one's fine. It's 8. This one will be times 2 times 2. And that would make 22 out of 8. Subtract by 19 out of 8. And what does that make? 20, 21, 22. 3 out of 8. We've got our answer. 3/8 of a meter more. Sandy, here she is. How much further did she jump? She jumped 3/8 of a meter more than Josh did. Think about that a little bit. Jared packed 1/3 of his luggage on Monday and 2/5 of his luggage on Tuesday. How much of his luggage has Jared packed altogether? That's question 1. Question 2 is how much more does Jared have to pack? Figure out what is being asked and if it's addition or subtraction. What's question A going to be? Adding or subtraction? That's the clue. That means add. How about question B? How much more? Yes, that's subtraction. So we'll put our addition sign here. We're going to add 1/3 and 2/5. 1/3 and 2/5. Now we have a problem because we have that pesky denominator who doesn't want to be the same. So we'll make them the same. They can both be turned into 15. Yes. So we'll times him by 5. So we have to times him by 5. We'll times him by 3 to turn 15. So we'll times him by 3. Now we'll go 5 for this one here and 15 for the denominator. And this is going to be 6 over 15. 6 over 15. And altogether we've got 11 out of 15. Altogether. That's how much he's packed. He's packed 11 out of 15 of his bags. How much more does Jared have to pack? What should we subtract? It's great that we know it's subtraction, but what do we subtract? Do we subtract 2/5 and 1/3? Do we go like this? 2/5 and 1/3, or the other way around. It's actually, no, this way here. Do we do that? No. If you did that, it would be completely inaccurate. It'd be wrong. What we subtract is, well, where he needs to get. Look, how much more does he need to pack? To pack for what? To finish. It doesn't say, but we assume, we know it's to finish. How much would the fraction be when he's done? It'll be a whole, right? It'll be everything. It'll be 100%, which is one whole. He'll pack everything up by then. A whole is going to be one whole. That's the big one. And he's got 11 out of 15. We're going to subtract those two, because he's packed this much and he needs to get to this much, right? He needs to get to a whole, which is everything packed up, but he's here right now. So we subtract those two. Now what do? We need common denominators. So you know what? A whole isn't good enough. A whole is 1/1. That's 1/1. But we can turn that into 15/15. 15/15, that's a whole. He's got 11 out of 15, so he needs 4 out of 15 more to go. When he packs those 4 out of 15, he'll have everything packed up. Last question. We have two lines. What is the total length of the two lines? That's question 1. How much longer is the first line? Decide. Adding or subtracting? Okay, question A, what did you say? If you said subtraction, no, not quite. What is the total length? That's addition. Total means add. So we'll just add 4 3/4. I'm going to change this right away to an improper fraction. What's 4 times 4? 16. Plus 3 is 19. So we have 19/4. Here we have 6 times 3 is 18. 19, 20. 20/6. You tell me what those two denominators can become. 12, yeah? 12 works. 4, 8, 12. 6, 12. So we'll multiply by what then? What do we times this by? Times by 3. So times that by 3. We're going to get some large numbers. This times 2. This times 2. Okay, let's times these here first. 3 times 19 is what? Well, 3 times 9 is 27. Put the 7 down. Carry the 2. 57. And the denominator is 12. And here we've got 40/12. That's not too hard to add up. We add them together to find the total, and we get 97/12. Yikes. That's a large fraction. What's the total length of the two lines? We have 97/12 of a centimeter. Well, what does that represent now? In terms of, wholes, turn into a mixed fraction. 12 goes into 97 how many times? Well, we have 12 times 2 is 24, and then 36, and then 48, and then what? 60, and then 72. That's 6 times, and then another 12 makes, what is it? 72, 84. Come on. 84, that's 7. Another 12 makes 96. So we have 8 times. It goes into it 8 times. That makes 96. Okay. We can go like this to prove it. We can go 12, 24, 36, 48. What's then? 60, 72, 84, 84, and then 96. Count them. 1, 2, 3, 4, 5, 6, 7, 8. That makes 96. So 8 times. That means we have 1 left over out of 12. So we have 8 whole centimeters if you combine these, and 1/12 of a centimeter left over. How much longer is the first line? How much longer? Sounds like addition, but ER, look at the ER, subtract. So you just take this one here. So it's going to take the bigger one. Always subtract big first, small second. So we have the 19/4 first. Subtract from it the 20/6. 18 and 2 is 20. And now we're going to have the same numbers, but subtracted. We're going to have 57. When we convert this, 57/12 minus 40/12. Okay, I just found common denominators. I didn't show all the steps because I did it in the last question. And then I'm going to have 17/12 as my answer. which when put into mixed fraction form, we're going to get 1 whole. 12 goes into 17 one time with 5 left over out of 12. Right? So we have 1 whole centimeter and 5/12 of a centimeter longer than line B.